Okay, so it's surface area and volume time. Good times. All we're going to be dealing with here in these videos is basically a cylinder. A Campbell's can of Pepsi, can of whatever. So, surface area, the formula here. Surface area is, again, this is all linked to the video I did on area. So these are just the calculations that we're going to be doing. So surface area and volume, 2 pi r, 2 pi r squared plus the height times 2 pi r. So if we have a radius of 12 centimeters, a height of 7 centimeters, we can just take these numbers, plug them right into the formula, and we end up with these values. Now, some students, I get different things, how they carry over decimal places, but just to show you here, so we end up with 1432.56 if pi is carried over to all decimal places. So if you use the pi function in your calculator, you'll get this number. But if you carry pi to 2 decimal places, you'll end up slightly out. And this is where students, can I, what's right, what's wrong. I'll adjust to whatever, however you guys use your calculator. But this is the more correct one, but either way. So the volume, pi r squared times the height, where we got here. So again, we just plug the numbers in. And if we carry pi to all decimal places, we end up with 166.72. And if we just carry it to 2 decimal places, you get 165. So just slightly out. This will matter if you're working for, say, NASA, and you're trying to get to Mars. You might want to carry over your decimal places. But for surface area and volume, I'm not going to make too big of a deal of it. So, if we want to solve for the height, we just deal with formula manipulation a little bit. So, the way I perceive these here is just really simplify what's going on. So you have, for me, you have a 1 plus 2 equals 3 situation going on here, where 2 pi, 12 squared, these are all being multiplied to one value. So these are all being multiplied to one value. So as far as solving the equation and having to move things around, I just sort of like to perceive it in these terms. So because they really are just a group. So here we ended up with 904.77, 527.79. So again, 1 plus 2 equals 3. So we want to solve for the height. So this is right here is built right into the height. So we would just want to get rid of this, move it over here. So now we have right here, this is left over. So we got 527.79 equals 1432 minus 904. So now we have a different sort of scenario going on, where you have the height times 2 pi r could be viewed as a 2 times 3 equals 6 scenario, where we want to get height by itself. So if we want to get 2 by itself, we just want to cancel the 3's, and you end up with this sort of. Sorry. So if the height times 2 pi r equals 527, and we want to get the height by itself, so we can just multiply or do the same thing, divided by 2 pi r, divided by 2 pi r. So the height equals 527 divided by 2 pi r, which equals 7 centimeters. So if we want to solve for the height, as far as volume is concerned, we got a radius of 12 centimeters. So again, we have sort of a 2 times 3 equals 6 scenario here, as far as manipulating the formula is concerned. So we got pi r squared, we got the r, we just plug that number in, 452.38 times h equals 3166, and we want to get h by itself, so we just cancel that out, bring it over here, so the height equals 7 centimeters. If we want to solve for the radius, as far as the volume is concerned, we have the height is 7 centimeters, we'll say. So we don't have anything in here. We got pi, but whatever. So we got the pi r squared times the height is our volume. So we have pi r squared times the height equals 3166.72. We'll just, we know the height already, so that's 7, so we'll just plop that in here, cancel it out. So we know that pi r squared is equal to 452.38. So we want to get r by itself, so we just cancel these out. Drop it over here. So now we have r squared is equal to 143.9, which is roughly 144. And to get rid of the square, we have to square root. We'll square root both sides, so r equals 12. So here's an example. Just try it out for yourself. I'll put up the answer. I'll give you a second to go through it, and we're just going to drop the numbers. You have the radius, you have the height, so just drop the numbers into the formula, and the answer is in 3, 2, 1. So there we go. Again, just put the answers in, just drop the values into the formula, and away you go. Let's just add something in here. The 2 pi r squared, here's your squared right here, centimeters squared. Then you have the height times 2 pi r. So that is also your squared area. So we're just adding up our square area, and that's where we get the centimeter squared. For the volume, just plug the numbers in, and here we have our squared area, but here we have the height. Here's our next dimension, so that's where we get our cube dimension. On to the next. So if we want to solve for the height, the surface area, solve for height, so so just pause the video here. R equals 4, height equals what? So solve for height using the surface area. I gave you the 175.92. We'll take a second, go through it. And here's the answer. So again, we just went through the same method, and the height ends up equal 3. On to the next. So we'll solve for the height for the volume. So the volume, pi r squared times the height equals 3619.11. The radius is 12. Pause the video, write it down. I'll put it up, the answer, in 3, 2, 1. So there we go. Again, went through the whole inversion process. And then we'll move on to the last, but not the least. For the volume, we'll solve for the height. Pi r squared times height, 763. So we'll just plug the height in. Pause the video. And the answer is right here. I thought I'd just take it down the chain, the process here. Takes a little bit to get to r squared and all that, but at the end of the day, r equals 9. And that's it for this video. Thanks for tuning in, and I hope to see you all next time.